Yes, my name is Crispin Keable, and you've just heard from IBM, which is why everybody's gone over to the other hall, I suppose. I don't know. But I have been asked to talk, or to run the session on big data readiness assessment. My background is that I come from the high-performance computing domain, and high-performance computing is actually a big data implementation in many ways. It's so, you know, from one perspective, I've been doing big data for 25 years or something. I think it's a really, really exciting time because, you know, now with big data and with this type of analytics, the kind of technologies and techniques that there are in high-performance computing are merging with, you know, essentially more of the mainstream. And, you know, I guess lots of people's perception of high-performance computing is that it's all about rocket scientists and particle physicists and people like that. Actually, that's not true, mainly because all of those people are now employed in the city, but also because the technologies have converged. And you know, people using HPC systems now to do all sorts of things which traditionally they weren't, like, you know, in the supply chain for manufacturing and things like that. So I'm going to cover the topics that I list here in this agenda. I'm going to try not to talk about the products that Martin mentioned. I mean, I do have some slides. I'll probably skip over them that do talk about those products. So I'm going to talk about whether it's right for you. I'm not going to give you any answers. Those are questions essentially for yourselves. What will it help you do that you couldn't do before? I'm going to major on one customer of mine, Desbury Laboratory, and go into who they are, what their thought processes were, and, you know, what they then did in terms of implementation. They're not at the end of the road by any means yet, but their aspiration is something I think which is a really interesting thing to do. Then what are the options? So as I said, Martin did talk a little bit about the options, and I do have some slides that cover that. So I wasn't going to go over those unless there are any further questions on those topics. And then what about preparation that you ought to undertake before we get started? And then what about the future? That's an area that really interests me, and the reason that it interests me is because it's coming really fast, as we all know, as people in the IT industry. So, you know, what you do today is going to be out of date really soon. So I'll have a couple of slides at the end that discuss that. So you've seen all this type of slide in the morning sessions. Essentially, you know, where is big data useful? It's useful across a wide variety of different domains. All of these people are, you know, people in all of these vertical industries are looking at absolute explosions of data. And, you know, the question is, what do you do with it, and how do you make it useful? So what I'm trying to look at with this slide is how we got to where we are today. It's kind of my view, if you like, of how we got to where we are today. And it's, you know, the issue that I see as I talk to different people is that, you know, analytics solutions have been put in pretty ad hoc in response to requirements that organizations have had. So they tend to be, you know, very much in a silo. There's a silo for one function and a silo for another function and so forth. And in fact, you know, thinking about, you know, risk management for a moment, I was talking to a customer a few days ago that has multiple silos just within that domain. 47 in a global organization, right? So one of the, and you know, what they see is a regulatory framework which is requiring them to manage risk more effectively. It's a financial institution, you could guess, I'm sure, to be much more integrated. So they're interested in, how do you integrate all those things together? Also, acquisitions tend to feed into the fact that, you've got one system that does something over here and you've got a similar system over there, and so forth. And what this means is that, the data is inconsistent, it's often duplicated, so it's not really well aligned with the business needs. It may perform its function within that small domain, but actually there are lots of questions where it's found wanting. So the consequence of all that is we need a way of looking right across enterprises, and the organizations that are doing that are deriving huge benefit. So my perspective is that people who are doing this are starting to get huge value. And for me, that's the key, is where you start is that value, where you start with a big data project is that value. Okay. I've got more to say about it in a minute. I'm not going to go into detail on this chart. So IBM has this business analytics optimization reference architecture overview. So that's what this thing is, okay? And what you see is all of the, effectively, so you've got, sources of data here and how you deal with them, content management here, master data management, data integration, so on and so on and so on. And what you see here is lots and lots and lots of tools, okay? Because we're in the same situation as, the problems I outlined on the previous chart. We have lots of point solutions, effectively, to specific problems. But that's not where we need to be. So, one of the things that, these are the problems that come out of that in these boxes around the edge here, I would say. But we recognize, one of the key first steps in terms of big data readiness, in my view, is recognizing that as a problem. And I'm sure, by the virtue of the fact that you're in this room, that you are already at that step. So, so this chart looks at how projects, what they're up to and why they fail. So my belief is that a big data project intended to examine, to uncover these new areas of value. That's all good. Integrate the data from the different silos, as I've discussed. The thing about the big data, the thing that differentiates a big data project, really key differentiator for a big data project from any other IT project, is what you expect to get out of it. What you expect to get out of it might not be the value that you actually end up getting out of it. And that fact is crucial, I believe, because you've got to let that happen. You've got to accept that an organization, I'm preaching, I suppose, a little bit, but it's my view that an organization needs to accept that that is a consequence of aggregating all these different sources of data. So it may be that you believe that you go into a project thinking that aggregating these sources of data is going to derive value by implementing cross-line of business efficiency. Actually, what it ends up doing is uncovering a source of fraud. That's a good source of value. The thing about big data is it's a new country that we're going into. That's what makes it so exciting. But you shouldn't expect a new country to be like, where you've come from. New countries are, by virtue of, they're new, aren't they? So that's what makes it so exciting. So this is why, this is a list of things I think about, why they fail. Because essentially, I mean, you can summarize a lot of these things into what I just said, which is that there is this expectation that you can write down on day one, this is the value that I want to get out of it, or the business is going to get out of it. And yes, it might be, but actually you might get some other bits of value. And actually, that's probably better, or at least as good. So anyway, that's the sort of, that's my view of the way in which big data projects work. So now I'm going to talk about Daresbury Laboratory, because they have just recently, over the summer, implemented a system, and talk about who they are, what their thought processes were, how they got to that process of implementation. And it's a big, big project, 10 million, 30 million pound, I think, total. So Daresbury Laboratory are a part of STFC, the Science and Technology Facilities Council, so basically part of government. So it's their job to fund big scientific projects. So they've got a background in funding telescopes, a background in particle sources for physicists, that type of thing. And a few years back, when I started working with them on this project, what they wanted to do was they wanted another big machine, big computer, and they went to the government and their funding source, central government, and they said, can I have some money, which is their normal route for doing this? And the government said, no. Why should we give you money? Well, what's this for? It's just another one of the same. So they basically went back to the drawing board and had a real rethink about what it was for, what value it would derive, and have really kind of turned the telescope around in this project. So this is who they are. This is the kind of things which they get up to. The facility that each one of these is an STFC facility. They have a big one at Rutherford Appleton Labs. They have an observatory at Chilbolton, which is a radio telescope. They manage optical telescopes abroad. And they have this Daresbury Laboratory, which is where they've done big IT projects before. They look into particularly materials sciences there. They have a lot of material scientists, and it was those material scientists who wanted to have the big new computer, big new shiny toy. Because the key challenges in the next century is essentially these types of things. So this is just an example, but what they need to do, those material scientists, is they need to be able to aggregate function right across a large range of different physical scales. So they need to expand their analytics capabilities beyond the siloed domain of applications that they had previously to this much wider domain. So that, as a requirement, if you're a scientist, fantastic. If you're a business person, so what? I mean, I'm sure that the scientists can get some papers and maybe get a grant or whatever, but actually, how does that really help? And so it was that discussion that really changed over the course of the last couple of years and then made the project fly. So what they recognized was that, so what this chart shows is their expertise, which is right down this end with the science and technology push. So they have some new ideas about materials and that type of thing. And they may develop a concept, but this is a million miles away from industry. And there's so much that needs to be done along the way here with all of these different steps. And so it was the recognition that they needed to bridge this gap from here to here that led them down the path to the implementation that they've got today. And so this was the vision, effectively, that they took back to, having been rejected, that they took back to the government. The government liked it. So the previous lot, they were the people who said no. This lot said, well, yeah, that's actually a really good idea, because they could see that, I mean, part of the business case, one of the key aspects of all of this is that, in order to get from the previous slide to this slide, obviously I'm simplifying, there was a big business case, and the business case had, hard goals in it. But what the goals were, what the business case was to essentially make the case that this is seed corn money. Yes, this is a big expenditure. Obviously, it's a big expenditure. But it's a big expenditure that is going to deliver real innovation, not incremental growth, or not small increments to applications or whatever, but big innovation to the economy. And at the end of the day, that guy there is going to get more tax revenue, and so he liked it. I mean, simplifying a little bit, but yeah. So about a year ago, he announced £145 million to go into e-infrastructure, which then got divvied up, and they were given £30 million. So there's a total of 40 million, big project. And that was really essentially coming back to the same thing of getting some equipment, but the focus of where they wanted to go and how they wanted to get there had been radically changed, and they got all the sort of the Prince there and David Cameron and so forth to come and open the facility. So big news, big deal. So their original business case centered around the technical and scientific opportunity and ignored the levers into business and ultimately into the economy. And that was the transforming piece, the transforming element, which allowed them to move forward. So what they actually did was to essentially combine lots and lots of different, so the model that they put forward was this model here. Essentially, instead of having an individual person working away on an analytics problem which may be of some interest, what we'll do is we'll identify a number of grand challenge problems and assemble the resources that are needed from wherever they may need to come to fix or to address that grand challenge project. Okay? So they've got some expertise here and here. We've got some expertise here and here, but there's lots of expertise that we don't have. And one of the things that we don't have is the grand challenge problem itself. So a key player, key collaborator in this whole scheme is business. A key rationalization or key rationale for these systems was going to business, and they're talking to all the big blue chip companies at the moment, but hoping to talk to great and small ultimately. So people like Unilever are very, very interested to develop new types of soap. And actually, that's the real driver. Unilever really get it. That's what they want. They want a step change in their innovation. They don't want to have all the expertise in-house. It's very expensive. And so this collaborative approach has worked. And the same is true for other clients of Daresbury. So it's built on a whole load of equipment with very big data requirements indeed. A total of 5 petabytes of disk and 15 petabytes of tape, all kind of glued together with lots of networking, and essentially running these analytic problems. And with these are names of technologies, which I'm not going to go into unless you're particularly interested. The data-intensive piece is particularly exciting in my view. So our rationalization, IBM's rationalization for being involved, and this is the kind of thing that we like to do, I guess, is that essentially this is the link to allow us to derive. IBM for the longest time has been doing lots and lots of research into areas like big data, but we need to leverage it. And using this kind of collaboration is an ideal way of doing that. And so that's what we did here. So I'm going to skate over these slides. These are, this is looking at how what you can do with big data, and I'm sure that you are familiar with this type of thing. And as I say, there are also obviously where different application areas can be used within different vertical markets. These are the different schemes of hardware and software that we have. Again, I'm going to skip over these pretty lightly unless there are questions. So Hadoop, you've heard discussed. We have a Hadoop implementation called Big Insights, which basically makes it more robust and industry standard. Vestas is a wind turbine company in Denmark who have an implementation of this. So each turbine costs large numbers of millions of pounds to erect. So what Vestas realized was that erecting it in the wrong place is a really bad idea, effectively. So what they've done is they've put in place a Hadoop cluster based on this Big Insights technology, which is able to model different prospective locations and also to figure out, with the wind conditions as they vary from day to day, how you get the best use of their installed capacity. Okay, so that's how they're using that technology. So quite a useful example there of a Hadoop implementation. The stream technology, Martin also referenced, that's basically data as it's kind of washing by, how you deal with that. So this is changing the model from data at rest to the data flowing by, and you've got a query sitting there effectively. And so there's an Asian telco using this technology. Essentially, the deal here, the value here, is just the very fact that you have such large volumes of data that you can't possibly analyze it on a conventional infrastructure, even a Hadoop-style infrastructure, just because the volumes of data. But the value that you get is based around how quickly you can get the insight from it. So it's while calls are happening, effectively, that you can possibly offer people changes to their tariff and that type of thing. And conventional data warehouses, again, Martin referenced that, and we have a variety of different flavors of doing that, from the deep analytic, or from the Netezza down there to smart analytics and just the software-only offerings there. And an example there from Pacific Northwest. So, and we also have a range of tools that essentially do the integration and governance, but again, I'm going to skip past that, essentially so that you can tie different schemes together and feed, a regular data warehouse from a Hadoop cluster or whatever. So what I wanted to move on to then was to look more into the future. And we are getting to this exascale. What does exascale mean? 10 to the 18, okay? 10 to the 18. That's just a big, big number. But that's how fast the IT industry is moving, okay? That we'll be at that kind of scale by 2018 to 2020. So that's 6 years away. That's not very long away at all. Now, who here, hold your hand up if you're going to buy an exascale computer, because I really want to talk to you. Probably isn't anybody, I admit. But it's worth examining, because that's where technology will be. The fastest computer that we have today, the petaflop systems, we don't have any of them in the country either, but we do have that technology in our businesses. So it's worth considering, worth thinking about, because that's what's going to happen. Those are the kind of systems that we're going to need. So those machines are going to have 30 million cores. Cores aren't getting any faster. Your Intel processor is not getting any faster. So 30 million cores, up from 1.5 million today. What does that mean for data? In order to make that useful, you need 60 to 100 terabytes a second. I mean, these numbers are just, huge. They're just vast. Disks aren't getting any faster. Disks are still running at, say, 100 megabytes a second, still similar sorts of I/O rate, transaction rate. So you need, if you just do the maths, you need, between 600,000 and 1 million disks for that. That's not going to work, is it? I mean, who can afford that? Just the disks, just the electricity for the disks. Doesn't make any sense. So in the real world, the world that perhaps we inhabit, so maybe one US government lab will do that, okay? But in the world that we inhabit, a single rack, just scale that down, it's going to have 300,000 cores, just one rack. Now we will have one rack, probably more, right? So we need to address these problems, actually. And it's going to require a terabyte a second of I/O bandwidth. So we absolutely need to know, need to address these problems. And so the reason I say that we need to address these problems is that people are, and if it's not you, it'll be your competitor, is my view. So data and how we deal with it has to change. Systems, how we build them, have to change. That's kind of my problem more, I suppose. So what this illustrates is the way that systems network together. So what I've got here is parallel tasks that are very, very parallel. So they require very little connection between the processing elements, okay? So that is, if you like, a classic Hadoop problem. For the stream data, that is this kind of network, looks like that, and but not all problems are either in that class or that class. So we have to think more about these more complex networks as well, possibly linked in terms of these very large numbers of machines. And what does it mean from a building the system perspective? So the computers that we have today look like this. So here's the processor, got a cache, got some memory, and it's got some storage. The application runs on the processor. In running on the processor, it calls out for some data, and the request goes out to the cache. If it's not there, it goes to the memory. If it's not there, it goes out to the storage. So then the storage turns around and says, much, much slower, okay, here's some data, give it back to the memory, gives it back to the cache, and there you go. So that, when I say we need to think of new ways of doing things, is not going to work in the future because of these huge volumes of data that I've just been talking about. So more and more, we're going to be looking towards this type of architecture, moving over to the right. So here, this is an example of a storage system where we have processing at the storage, actually embedded in the storage. And we already do this today, and it's this Netezza product. And what that allows you to do is to filter the data that's actually going into the regular computer, if you like. So just to cut down on the volume of traffic that has to go all the way into the more general purpose system. And as we move into the future, into that sort of 300,000 core future that I mentioned, we'll get more and more of this, where there's processing in the memory, perhaps, processing storage class memory. So storage class memory is a new introduction that people are beginning to think about. So that's flash memory instead of disks, effectively. That's how you get around that 600,000 disk problem to deliver big bandwidth. But there'll be processing in there, and there'll be processing in the storage as well. So that is the way that I see life. We have lots and lots of different ways of cutting the big data cake, as I've mentioned. But actually, the summary, in my view, is it's about defining value within your business, and then going out to identify what the right piece of the puzzle might be, whether it's visualization for data to derive value, to derive better value out of it, whether it's a conventional data warehouse, or whether it is a Hadoop system. Those are subsidiary questions, if you like. So that's what I have. It was going to be an interactive session. There's been no questions. Are there any questions now?
Do you just elaborate a little bit on, you've got the Hadoop system and the teaser.
Yeah.
And you kind of showed how in the slide before this, which had the memory class and the data storage and stuff. How different is that Hadoop to the middle layer?
So Hadoop, as an architecture, is built out of the cheapest systems that you can possibly purchase, but just lots and lots of them. So it's basically built out of that thing, but replicated as many times as you can afford. Okay? So it focuses around the storage typically, because it typically is the volume of data that you wish to process. That's the key factor. But then you go to the lowest cost storage that you can find, the lowest cost memory, the lowest cost processors, because you want to replicate that as many times as you want. That is the essence, if you like, of a Hadoop cluster. Okay? And it's parallelizing in between. So in this slide here, each one of these things here is one of those things here. So the architecture of the Hadoop cluster, or the architecture of the Hadoop application, is the ability to chunk up the problem into these mappers, which do the bulk of the work. Okay, so they do the search maybe on their chunk of data, and that's where most of the work gets done. And these reducers, which aggregate the answer so that you have essentially a single, or a single query coming back. So Google operates this. When you type your search terms into Google, the search terms get farmed out onto all of these mappers, which all have chunks of their database on them, and so it's parallelized many, many ways. But there's no interaction between that guy and that guy, because each one of these things is essentially independent. But then the search needs to be aggregated, so that's what this reduce function does back to you. Okay, so that's Hadoop. Netezza is a conventional data warehouse. So it's running a conventional, what is implemented within Netezza is a conventional database that is accelerated by some special source. Okay? So there's technology in Netezza right at the disk, which is FPGA, Field Programmable Gate Array. So it's a special type of chip which allows you to chunk up the SQL and farm it out to across the data, so that you don't have to process all of the data within your regular database. That's the difference between Netezza and Hadoop.
There's no harm in having a mixture of those two, depending on what you're trying to solve for.
it's function dependent. Absolutely no harm at all. And in fact, previously, I think that there will be lots of situations where you do need both, because the data warehouse will continue to be useful, but more and more as we look to analyzing and processing unstructured data, you can't do that on a conventional data warehouse. You have to do that on a Hadoop cluster. So unstructured data can't go there. Deriving value from text, PDF documents, that type of thing, searching that kind of thing and getting sense out of it, doing natural language processing. You're familiar with this Watson project, maybe? So Watson is a project that IBM did about a year ago, where we built essentially a Hadoop cluster to perform in a game show in the US. Okay, so the game show is quite similar to University Challenge, but there's money involved because it's in America. So the people get prizes, money prizes, and we implemented a Hadoop machine called Watson, and it finally won against the world champion. Two people one who'd won the most number of games, and the other person who had won the most amount of money on this game, which is called Jeopardy. Okay, and it is an extraordinary tour de force what they did with that system, because they started by just saying, well, what if we search the web, like Google? It doesn't work. You get maybe 30% of questions right by doing that. And that's kind of only when you're quite good at picking your search terms. So you need to automate, the problem with conventional web search is that you need the user to define the search terms, okay? In business, that's a problem. Actually, what we really want to do is we want to figure out where things are going wrong, or where value may be derived. So we want to automate that process of identifying search terms. And that's what this Watson process did. Yeah. So, but yeah, I mean, absolutely, horses for courses. Any other questions?
You said that input-output bandwidth is likely to remain sort of the same order of magnitude, just going to go forward to the future. So isn't that going to essentially constrain, the developments of what you were talking about on that slide in terms of the X blocks, all that sort of stuff, the millions of disks? I mean, I don't see how you can get around that if your height as well is still the same.
That's why we need this storage. That's why we need to integrate into our computer architectures things like this storage class memory. So when I said that the I/O bandwidth is not changing, what I meant is a single disk spindle. The technology, I mean, it gets a little bit faster over time, but not really by that. Not by the extent to which we need it to, not by orders of magnitude. So we have to have another layer of storage to be able to hold the data set, the working data set that we are working with. And that's what this storage class memory is. People are thinking about doing that now. It's not really a product yet, but people kind of at the bleeding edge are beginning to think about doing it because of exactly seeing this problem.
We're not already seeing lots of solid-state disks available today.
Yeah. I mean, basically, that's what I'm talking about. It's that type of thing, but it's using. So, how do you use SSDs today? Well, there's lots of different ways of using SSDs today, but having it integrated into the hierarchy of a system is what I'm talking about. So that from a user point of view, from a user perspective, somebody who's just wants to run an application and not have to worry too much, it just gets used by the system in the same way that memory just gets used. And if you go outside of memory, well, it pages. And today, it pages to there, okay? And that's slow. So in the future, we don't want it to page all the way to there. We want it to page to something that's a bit faster so that we get better utilization. And we want a bit of intelligence in this layer so that the right data is available for us, when we want to use it. So we want software tools built into this thing that actually do the right thing. And that's one of the things that we need to work on as well. Yeah.
Quick question.
Yeah.
If I'm a medium large size business
Mm-hmm.
and I want to make the most of big data,
Yeah.
I might have legacy systems and I could work on petabytes of data, etc.
Mhm.
I want to make the most of this competitive package.
Yeah.
Do I invest, say I've got to invest up front in the beginning,
Yeah.
do I invest now or do I wait for a period of time? Because I'm thinking as a CIO, adaptability, future legacy, etc. across the whole multitude, storage, processing, etc. So I work for RBS.
Right. So both approaches are possible of investing now. I mean, obviously that's true. But if yeah,
an information warehouse.
Yeah. Right. So
People don't. I think the worry here is to get onto this level of thinking.
Yep.
People are scared of investing for the big in hand.
Yeah.
To then find out it needs to be redone in 4 or 5 years' time.
Okay. So I believe that first of all, you don't need to invest. You don't need to do it all yourself.
Certain companies will be restricted, like healthcare companies, banks.
They have security issues associated with them, for sure. But one of the things that we aim to do is to help you manage those issues so that you can do proof of concept type work outside of your organization and manage the security issues. I think that, so I think it is possible to undertake that kind of an engagement, actually either internally or externally, but where you don't have to do the full up thing straight away. I think that what's clearly happening is it's dynamic. It's extremely, the whole big data area is extremely dynamic, and so now there is great opportunity, but there's attendant risk. So the opportunity that you have is that you will get a big march on competitors by investing now. Things will settle down over the next few years, and it will become clearer and easier to do. People will get all of these tools, lined up and working together better, and there'll be reference cases, in your industry to solve particular problems, that type of thing. But by that time, your competitors may well have already done it. So that's why I say, both answers are good, and it really depends on your appetite for risk, in my view.
Not weird, like things like platform as a service or infrastructure as a service.
Well, that's yeah, but I mean that's why you need to address the security issue. Yeah. We done?
The other session is great, so whenever you...
Okay.
I just have one.
Go ahead.
If there's time. Would you recommend any sort of profiler type tools that people generally in this space would use in terms of monitoring what those usage are per those layers?
Yes.
And is there a system that then automatically adjusts this on a daily basis to say, I want to change the rate settings on that because that's being utilized 50%, 80%, so I'm going to change that to rate 0 on that, I'm going to move it off to, solids because it's actually, 10% of the
Yes.
Do people optimize that?
Yeah. There are tools which allow you to automate that process.
Real-time optimizing.
Yes.
Maximizing.
Yeah. So for data handling, it tends to be, it won't be on a kind of second-by-second basis, but on a day-by-day basis, because we are talking about, normally, we're talking about moving large quantities of data around. But yes, we do have tools like that, which, be happy to talk to you some more about. Yeah.
It becomes self-learning though as well, can't it?
Can be.
It's self-learning in terms of
Yeah,
the requirements of the
Yeah.
system basically suffer and to say, okay, on this,
yeah.
you know, adapt itself. I think Google has that in place now.
So one of the things that we so it's database. It's a database effectively, and you can implement database rules that you can put learning into. So it's just SQL actually, but it's SQL focused on your storage infrastructure that allows you to where the data will move about in an automated fashion. Yeah. Thank you very much.